All right, this problem is a little bit of a doozy. They kind of want us to do everything we can with it, which is fine. That's what we'll do, everything we can. So we want the y-intercept. That's easy. Y-intercept, when I plug in 0, I get out 2. So, um, let's see. Critical numbers. Let's get that by taking the derivative function. So negative 15 plus 18x minus 3x squared. Then I got to set that equal to 0. So let's factor out a 3. Um, so negative x squared plus, you know what? I'm going to factor out a negative 3. Makes my life a little bit easier. So negative 3 comes out, and then I'm going to have a negative 6 and a positive 5. Doesn't that make life easier? So negative 3 here, x minus 5, x minus 1. My two critical numbers are x equals 1 and 5. So I've done the y-intercept, I've done the critical numbers. Now for my intervals of increasing, decreasing, I'm going to do a number line analysis to assist me. Critical numbers of 1 and 5, plug values into the derivative, start with 0. I have 1 negative, 2 negative, 3 negatives, so negative. Plug in 2, I get out 1 negative, 2 negatives, so positive. Plug in 6, I get out just 1 negative. So my intervals of increasing and decreasing, my function is f is increasing on 1 to 5 because f prime is greater than 0. F is decreasing on negative infinity to 1, union 5 to infinity. That is because f prime is less than 0. So now I've done that. Okay. Relative extrema, they want the x and y coordinates. So for that one, I know I have a relative min at negative 1. So a relative min where f prime changes, excuse my handwriting, from negative to positive. That is going to be the point 1, and then plug it in. I get out negative 13 plus 9 is negative 4, minus 1 is negative 5. I hope I did my math right. Relative max is where f prime changes from positive to negative, and that is going to be at the point 5 something. Let me see here. 2 minus 75 plus 9 times 25 is 225 minus 5 cubed, 125. So now I've got 225 minus 225, 27. I think I did that right. So now I've got the relative extrema. For the concavity, I have to take my second derivative, and I'm going to end up with 18 minus 6x. So my critical number for this is x equals 3. I'm going to do another number line analysis, label it f double prime. If I plug in a value like 0, I get out positive. Plug in a value bigger than 3, I get out negative. So intervals of concavity are going to be concave up is where f double prime is greater than 0. So f is concave up, f double prime is greater than 0. That's from negative infinity to 3. F concave down, where f double prime is less than 0, that is 3 to infinity. So now I have intervals of concavity. Point of inflection, POI, there's just one of them. That's at the point 3 something, and let's plug it in. 3 minus 45 plus 81 minus 27. So I have 84 minus 72, or 12. So there is my point of inflection. An accurate sketch. So the way to do an accurate sketch, and I'm going to do it really small, if you don't mind. So I'm going to have y-intercept. I'm going to have relative min at 1, negative 5, relative max at 527, point of inflection at 312, and here I go. I have to start decreasing, increasing different concavity, and then I start decreasing again. So that is the best I could do given the space that I'm given. Okay. That actually makes sense, by the way, because it's a negative cubic function.